In this video, we're going to look at a couple examples for parametric motion. So quick reminder, parametric equations, we have a parameter, in this case t, that is in both equations. So we're going to have an x equals equation and a y equals equation with the parameter t in both. So that parameter, helps us figure out the x and y value based on what t is. So we're going to look at some real-world examples where the two parametric equations represent an object and the direction and speed that it's going, as well as another force that's acting upon that object. So our first example here, we've got a plane that's flying from Memphis to Albuquerque. We'll say it's 1,000 miles. And the plane is going due west or straight west, 250 miles per hour. The wind is blowing 20 miles per hour from north. So that means it's blowing south. So our plane is going straight west, but there's a wind that's blowing south. So first we want to figure out where's the plane after 4 hours. Well, we have to put together our parametric equations. So quick pause and see if you can think of what that would look like. So for our plane, well, that's going west. If we think of an XY grid, that is going along the x-axis in a negative direction. So we're going to have an x equation with a negative 250. And our wind is blowing south, which would be the negative direction along our y-axis, so it's going to have a negative 20 in it. So that ends up being x equals negative 250t and y equals negative 20t, where t represents the time. In this case, it's going to be hours, and these values here are going to be in miles. So after 4 hours, well, we just substitute 4 in for t, because that's what that represents. And we end up with x equals negative 1,000 and y equals negative 80. Now we can't have negative values for distance, so the negative is just telling us what direction it's going. So since they're both negative, that means we're going west and south, just like it indicates up here. So if we go ahead and draw a triangle using that information, our plane, after 4 hours, goes the full 1,000 miles straight west, but the wind would be blowing 80 miles worth for 4 hours. And we have to have an origin somewhere, and so we'll just use our starting point at Memphis as 0, 0. So now we're going to look at how far did the plane actually travel. So that represents this distance here, where the plane is traveling west, but the wind, that force acts upon it and is going to change direction a little bit. And then we're going to look at what is the speed of the plane during that time, and then what is the bearing, or what's the angle or direction. So go ahead and again pause and try it yourself. So how far did the plane actually travel in 4 hours? We set up our triangle. Here's the plane, here's the wind, but combined that gives us this distance at a very small angle. So we use Pythagorean theorem, and we find that the distance traveled is just a little over 1,003 miles. And now we want to find the speed of the plane. Well, I noticed that this side of this leg of my triangle is so much smaller than this one here, which tells me that my angle is not going to change very much, or my angle is pretty small. My distance here and the speed of the plane with that wind acting on it is not going to change much. Like you see here, this is not too much greater than the 1,000 miles we started with. So I'm going to expect that the speed is not going to be too much more than 250. Well, we know speed is distance divided by time. So our new distance is 1,003. We want to make sure we're not rounding. We're putting the exact value in there. Divide by 4, and that gives us 250.8 miles per hour or so. So again, not a huge change because of how small this number 80 is compared to the 1,000. And then last question, what's the bearing or the angle? Well, we've now found the values of all three sides of our triangle, but because these two were given and they're integers, whereas I could have an error in this, or I'm going to make sure that I use the exact decimal. I'd rather just use these numbers to be safe, so we can use tangent, and that gives us an angle of 4.57. So that's at this small angle right here, but we are dealing with directions, so we have to think of what direction this is in terms of north or west. So a couple ways you can say it. It's 4.57 degrees, or if you're going a little further, 4.573 degrees south of west. So we were originally going straight west, but this angle is south of that direction. Or if we have a bearing from straight above at north, well, we go clockwise from north all the way around to where that angle is, and it's just a little shy of 270 degrees, so we subtract that value and we get 265.4 degrees or so from north. Okay, second example, we got a hot air balloon here, and it's rising at a rate of 15 feet per second, and the wind is blowing west from the west 24 feet per second. So similar to the last example. So go ahead and try to write the parametric equations for this. Oops, I showed it. That's okay. So again, think of an XY grid. Balloon is going straight up. That's a positive Y direction. The wind is blowing from the west, so it's blowing it east. That's a positive X direction, so we're not going to have negatives in our equation. So we end up with X equals 24t. We're going 24 feet for every 1 second represented by t. And that's to the right or to the east. And the hot air balloon is rising 15 feet per 1 second represented there by t. So now we're going to use those parametric equations and figure out if we're going to be able to clear this windmill. So let's say we've got that wind blowing today and we're taking off from here, but we don't want to take off unless we're sure that we're going to clear the windmill. So the windmill is 175 feet to the east and it's 95 feet tall. So we need to, once this hot air balloon goes 175 feet, we need to make sure that it's at least 95 feet up in the air, or we can measure once the hot air balloon is 95 feet up in the air, has it gone 175 feet yet or not? So we can plug in 175 feet in for X, because that's the distance towards the windmill, to see at what time is the hot air balloon that distance, and then plug that T value in to see what the height of the balloon is, to see if we've cleared the 95 feet. So we, like I said, plug 175 in for X, and T is about 7.3 seconds. So after 7.3 seconds, rising 15 feet per second, the hot air balloon will be a little over 109 feet in the air, and that will be enough to clear the 95 foot tall windmill. Again, if we want to plug in 95 feet for Y and see once we get to that height if we've gotten to the windmill yet or not, we could do that instead. So we plug in 95 for Y, we get a T value of 6.3. So after 6.3 seconds, the the hot air balloon is 95 feet in the air. And if we plug that time in to our other equation, we get a distance of 152 feet, but the windmill was 175 feet away, so that tells us we have not gotten to the windmill by the time we get to the height we need to. So either way, we find out that yes, we would clear the windmill.